Hi guys, this is Sairag. I and my friend V are here to explain the physics phenomenon of inverted shadows. What? Yeah, I know. Inverted shadows? Come on, dude. We know inverted shadows is a term that you've never heard in your life. You've heard of inverted images because you look into your mirror. But what about inverted shadows? You've never looked at a shadow that's been reflected, right? Let's find out more about this. My friend V is going to help us in our experiment.
Now let's see the materials needed for the experiment. So first, mainly, we need this mirror, which reflects light, and this magnifying glass. This is separate, and we need to pull out pen as an object. What the heck? And this is a pen. So we are going to show that when like shadow falls on the magnifying glass, it will reflect off an inverted shadow of the the pen. And this is the mirror, which shows the we'll show that the shadow is getting reflected by the mirror, which which you guys think it's not possible. I know.
Of course it's not possible. You're just idiot.
Yeah.
Okay guys, so now we're back with the things that we are using in the experiment right now. So we have a magnifying glass, we have a normal mirror, we have my book which does not play a role, and I have the last remnant of my childishness.
Yeah, which can be useful for this video.
Yeah. So let's go ahead and try to see how shadows are being reflected from a normal mirror. This is how the setup is going to work. Obviously, we do not have the lab equipment that famous physicists have, but we'll make do with whatever we have. So we're going to keep our mirror like this is going to shine the light, and we're going to at the back at the screen here. We're going to show the reflection.
The screen is where the shadow will appear.
So we're going to show you how a normal mirror reflects a object right now. After using a couple of milestones, we can get a normal.
Is that you're again using your eyes?
Of course. I'm sorry, that's my camera disease. So now once we have this, let's go ahead and try to see the shadow of the reflected shadow of my toy.
Yeah, right. So what the theory suggests is that this when the light falls on this, the shadow is going to fall here, and it's get reflected on this surface that we see here. So whatever this acts as a boundary here, and only on within the boundary you'll see the shadow here. So let's do this experiment. So let's place a toy here. So many of you will see that the shadow will fall on the mirror, and then when the shadow falls on the mirror, you'll see that a dual image is formed here. But why two images? Why? Siddharth will explain.
Well, you know that the first image is caused by direct shadow reflection of the object that we are using, and the second image is formed by the reflection of the first shadow image reflection. If that didn't make sense, I can't help it, but it is what it is. It's quite simple. Actually,
it's quite simple. See, when I held the toy in the middle, like our theory suggests that the shadow is getting reflected, but the second dual image, which is this small image, and this big image is the actual reflection of the shadow. That this second image is a reflection of the first reflection of the shadow. That's the thing.
That's pretty not so straightforward, but come on, guys.
Yeah, but come on.
We expect you guys to understand stuff like this. Come on,
that's
guys.
what.
You're amateur scientists, goddammit. Okay, let's. What if now we substitute this with one of these? Let's find out after change a couple of camera angles, because you have to change a couple of things. It gets tedious. Basically, now we're taking this and we are reflecting the light coming from this over here that forms some kind of a blob of
light where the shadow appears. That's the boundary where the shadow appears.
Now I'm going to produce the shadow while V is going to take care of the rest of the reflection and all that. And let's see what really happens and whether the shadow is getting inverted.
And
or not.
note that that is a real mirror, but this is a lens which is going to reflect the light.
Yeah, this is the lens that's reflecting.
And this is a
light.
convex lens.
Yeah, so it's a magnifying lens. It's not a mirror, but it does act like a mirror in certain ways.
Yeah,
but let's see why. How the reflection comes out, shall we? Okay, guys, I got this here. Now I'm gonna try to produce the shadow over here, not directly, but I'm gonna put it in between the reflecting surface and the source of light. I'm gonna put it right in between here. We're gonna observe the shadow.
Stop! You are again doing that.
Is
it a disease or what?
Yeah, it's like some kind of disorder that I cannot help. Okay, so I'm just putting just a pen from the bottom. You have to trust me here.
See?
Can you see? Oh,
yeah.
Can you see that?
Can you see that? See.
I have kept it from the bottom,
but the shadow is.
The shadow is coming from the top. Okay. Did I?
I know it's not so clear, but see, guys, see clearly. Yeah. See.
This is quite ridiculous, right here.
It's so ridiculous. It's an inverted shadow when the shadow of the pen is reflected here as an upside down shadow.
Let me just try to focus that. And let's try left right, okay?
Left right.
I'm going to insert this from the left.
From the left.
From the.
No,
this
the
is from the
hypothesis
right, right?
is.
It should be coming from the right. It is coming from the right. So if I insert like this, it comes like that. Yeah, it's again showing dual images because this also acts partially like a mirror, but that's quite interesting. That if I
Oh my god!
This is quite crazy.
This is quite crazy.
Okay, we just saw the experiment that we did here, but we still. Oh shit! This is okay. But we don't know yet the phenomenon why it happens. So we have a couple of theories here. I'm going to present my theory, and V is going to present his.
You can Google it on internet, but you won't
find anything.
You won't find anything.
That's what we didn't find anything. Of course, you'll find ours if you Google or not. I don't know.
Very funny.
Yeah, of course. Anyway, let's take the magnifying glass here. This is a disclaimer. My drawing is really bad.
Yeah, it's very bad.
Not that
But
V's
still.
is any better, but still.
Eh.
Okay, so we have our magnifying glass right here, right?
Yeah.
Then we have our object. Let's be a pen. There we go. And then you have the light source. Let's just make a torch. Of course, we used mobiles.
No, any light is enough. Any white light is enough.
Yeah. And then we have the surface.
Yeah. So it's a screen where the shadow appears. So.
Yeah, so we have this. So basically, what happens is, what we observe is that this shadow is upside down. Okay, no, it's straight here, right?
Yeah, it's straight.
It's weird from the starting itself that there is a shadow
on a glass. On a
this.
On a reflecting surface.
So the shadow is on a reflecting surface. That itself is quite intriguing by itself. But here's where it goes haywire. The reflection just
shut
goes
up and
here.
stop talking.
Okay, I'm sorry. I should speak in the
accent. In the accent.
Yeah, in the English. Indian the accent. Okay,
yeah.
I'm sorry. So let's see here. We have the reflection here, but what happens here is the shadow is inverted.
Yeah.
The shadow is inverted. How is this supposed to happen?
Actually, see, when the magnifying lens reflects the light, only the boundary of the magnifying glass is seen here. That's what Sairag drew here as a circle, and then only within the boundary the shadow can appear as an upside down shadow.
Correct, V. But why does the shadow get reflected?
Yeah, how can the shadow get reflected? It contradicts the theory where shadow has no mass and you can't reflect and shadow. Shadow is an absence of light. You can reflect an absence of light.
Okay, coming to my theory one.
No, it's
I spelled theory wrong. I'm sorry. I'm just not an English student.
theory. Oh my god.
Theory.
Oh my god.
Coming to our theory one.
I'm going to get steroids. I'm going to get steroids.
Okay.
Theory.
So now what if light itself, the shadow itself is not getting reflected? What if the light? Okay, this is all light, right? It's all light, photons. So what if the light is getting reflected in such a way that only these, all the light is like getting reflected. How do I do that? How do I draw this? Yeah, only the light is getting reflected. So the shadow technically isn't getting reflected, but only the light is getting reflected. And how do you define a shadow? An absence of light, right?
Yeah.
It's an absence of light. So if light, if light only reflects in certain regions, then what should happen is the area where, see, for example, this corresponding photon goes here, this corresponding photon goes here. So these photons around this shadow, there are no photons on the shadow, note that, will correspond to these photons on around this shadow. That means that only the shadow is not getting reflected, but only the light is getting reflected, which is perfectly fine with physics. Physics says, okay, light, photons, you can bounce off the surface. It's fine. But the shadows, I know, I should not do that. But shadows are not getting reflected. It's just the light that's getting reflected. Of course, this is just a theorem. This might be wrong.
But why? If the light is getting inverted, why is the shadow getting? It's an absence of light. If in the absence of light, why should the shadow get inverted? Only the image can get inverted because of a reverse of photons.
Okay, let's consider this. If we take a ball of this, of course
ball?
That looks that's not a ball and that looks like somebody's butt. But I'm sorry. Just imagine a ball like this. If you laterally flip it, right? If you flip it 180 degrees.
It's not laterally.
That's not lateral, right?
It's vertically inverted.
Vertically inverted. Then you get something like this. That's not somebody's heart. I'm really bad with drawings. So if you 180 degree turn this is what's gonna happen. I think that's exactly what's happening here. This is marked by the shadow. Why is this looking like some guy peeing? Okay, fine. So this.
Draw a correct ball. Idiot. Okay. See, this is the ball. No. How can you invert this? Okay.
Yeah, we'll keep this. Okay.
Okay, this is correct.
Because the ball is still going to be a ball.
Yeah.
Okay. So this area where light is in there is getting flipped, so that this area, like what happens here is, I think the what do you call this, magnifying glass is flipping all the photons here in such a way that only a certain part of light is not.
Okay, even if the photons get inverted, why should the shadow get inverted? Because it's an absence of light. It is not happening because of light.
Yeah, that's one of the drawbacks. Oops.
Yeah, but the same setup, if you do without the magnifying glass, only the pen and the light, what would you see? You see let the surface be here. You would see the shadow here as an upright, shadow. But right after you keep the magnifying glass, why is it getting here? Means the shadow is getting reflected here. But how can a shadow get reflected? That's the, drawback or, contradiction you can see. So that's all of the theories put forth by us.
Yeah, but please work on this theory.
Please work on this, and you can't find this on the internet except our video. So please, you work on yourselves.
Yeah, please.
And be junior scientists.
Yeah, come on, guys. Or he's going to head the research of the experiment.
That's a lame name. Okay.
Let's go to the.
Now, for the experiment, we need the following.
Cut this thing. Cut the.
Yeah.
Your nose looks like an infinity symbol.
What the?
Hey guys, this is Sai Raghav along with V, one of my friends. Today we're going to try to explain the phenomenon, the physics, amazing phenomenon of inverted shadows. Not images, inverted shadows.
So what's up in your sleeve, Sairag?
Yeah, that's nothing much interesting, but we have something really interesting coming up. One of my, I talked about V here. So, oh shit, no, I just screwed this up. Hey, don't interrupt me, please.
Okay.
We here at Science Geeks are trying to, investigate a cool physics phenomenon that is inverted shadows. What? What did you just say, Sairagam? Inverted what? Yeah, that's right. You heard it. Inverted shadows.
It's inverted, not inverted images. It's inverted shadows.
Yeah, okay. We've heard of inverted images. You know the mirrors, the jazz, 6th standard physics stuff here. But what about shadows? What? I have to come up with a...
I'm anonymous.
Yeah, you're anonymous. No, you're not. You're an anonymous. Oh, sorry.
No. Stop creating stupid puns.
Okay, wait. So we have to get you a pen name, right? Just like I have Sai Raghav, you need something. What would you choose?
I will choose V only.
Of course, so that we can make the video.
When the hell did you record the video?
I was recording it all the time. Okay.